Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. Today we're going to start the first class for A-level Edexcel AS Unit 1 for physics. And as all of us know that in this topic, one of the hardest topic for mainly most of the students, and it will be a huge jump between what they talk in the IGCSE and now in A-level, because as we know that the IGCSE, it's easy major topic, okay, and the questions, they are not that deep, okay, relative to the A-level that we're going to study a lot of things in deep. Okay, the depth of the topic, it will be hard, and even the top of the depth of the question. Now, what are the main things in unit? We have main two blocks in unit. Okay, unit 1, we have general physics, mechanics, and solid and fluid, the first topic. Okay, second topic, they are what? Okay, we have two topics here, general physics and solid state with the fluids. And usually the general physics that all of you heard about it, okay, from the IGCSE, okay, it will not be the same thing. It will be critical thinking. It will be a lot of ideas, new ideas, a lot of phenomena that they bring it in the exam. Okay, it will be the first time that you hear it, and you have to make relationship between what you study and how you put it on words or calculations or physics words, okay, on the phenomena to explain it and to find the solution or get conclusion about if it's correct or not, or some student suggestions if they do that or that, okay, what are the explanations. So now in this topic, okay, from while to while each worksheet, okay, I'll give you working as physicists, okay, in the beginning of each of these worksheets before we start the topic, okay, because we have a lot of information that we have to know it before we start the topic. Now I'm going to start a few things, okay, as a physicist, okay, we have to know it before we start talking about mechanics and motion. So first of all, we have to know what's the meaning of scalar and vector. And since you are talking about study it in the IGCSE, Cambridge, Edexcel, or Oxford, the scalar are quantities that have what? Exactly. Thank you. You can send me on the chat. Yes, of course, all of you. Which have what? Magnitude. Exactly. And what? And unit. Exactly. Magnitude and unit only. And vector quantity, they are the quantities which have magnitude and unit with what? With a direction. Excellent. Thank you, Yusuf. Thank you, Noor. Thank you, Lama. With a direction. So the idea here, the difference between scalar and vector quantities is the direction. But actually, the direction, it will not be the same as we study it in the IGCSE. It will not be simple. You are going to see that during this class and next class, inshallah. Okay. For example, I need to give you several examples about things that they are scalar and how they can be vector if they have direction, or neither. If they don't have direction, it can be scalar, or things that always have direction, that it's vector. For example, send me on the chat. Time. Time, is it scalar or yes? Thank you, Lama. Thank you, Yusuf. Time, exactly. It's a scalar. Unless we're talking about time travel or multi-universe dimensions, okay, we are talking about vector here because we can go forward, backward in the time or in other universe. Okay, so time is a scalar and doesn't have things similar to it in what? In vector. But if we go to another example like speed, it doesn't have a direction. When it has a direction, what it will be, what we call it. Yes, send me in the chat. Thank you, Yusuf. Another one, huh? What we call it? Bravo. A third one, huh? What do we call it? Exactly, we call it what? Velocity. So velocity, since it has direction, okay, that means it will not be a scalar anymore. It will be vector. Other examples, okay, like when we talk about mass, okay, the mass doesn't have direction. But if it has direction, it will be weight. Okay, and actually it's not, they are not the same thing. Weight and mass, they are not similar at all, because mass is the amount of matter the object has, while weight is the gravitational force. That means all forces, they have direction. That's why they are vector quantities. Okay, good. Okay, now another example for this, okay, is distance and what? And displacement. Now, one of the questions that I remember that they bring it maybe 15 years ago, displacement, is that we have a person or an object that walks from position to another position, to a third position, to a fourth position, okay, like this. And they ask about the speed, and they ask about the velocity. Now, all of us, we know that speed is equal to what? To the total, what? Total distance traveled in this, okay? So total distance. That means I will add all these together. I will add the distance that traveled in the first from A to B, for example, then from B to C, then finally from C to D. So that means I'm talking about the whole distance here. Okay, divide by what? Divide by time. But velocity, as you know, I'm not going to add all the distances from A to B to B to C, then from B, C to D. Velocity, it's the displacement directly from A to D, and divide by the same time. And I will mention, after I got the answer, I have to mention the direction, which is to the right, for example, or to the east. I remember this question, and it was clear, and a lot of students, they don't know how to realize it. Okay, especially if they are not A and B, they are not at the same level. There is angle, and you have to find how much is the angle, use tan inverse and something like this. Okay, other examples. Who can give me other example? Yes, temperature. Thank you. Temperature is a scalar, and it doesn't have vector quantity. Another example. Who can give me other examples? Exactly. Now we know that work, energy, okay, power, and efficiency, and all these, they are relative to each other. They are scalar quantities. But if I make similar equation, okay, and it has these things with direction, it will not be work and energy and power. It will not be scalar anymore. It will be a quantity that has a direction, which is be vector, like moment and what? And momentum. Okay, so all these are what? Are examples for how we can convert scalar quantities to vector quantities and vice versa. Yes, acceleration. Acceleration, as we know, it's what? Bravo. Acceleration is a vector quantity that has no what? No scalar quantity. And there is many examples, okay? Because we know that in physics topic, we have a lot. For example, in electricity, electric current, electric resistance, electric voltage, okay? EMF, okay, potential difference, all these, they are what? They are scalar, even if they know the direction of the current. Now, all these, they are scalar. I'm talking about the direction to the right, to the left. I'm talking about the direction, not in electricity, not in the wire. I'm talking about in real life, okay? So all electrical quantities, sorry, all electrical quantities, we assume that as a scalar because they don't have direction. Okay, this is the first thing that we have to know it, okay? Working as physicists, we have to know what they are. They are not the same quantities. We can divide into different categories according to they have direction or not, scalar and vector. Displacement from where we are going to answer questions later on, Shah. But displacement, it's from initial position to final position. That's displacement. But distance, I will add all the distance from A to B, from B to C, then from C to D. Okay, so the distance is not as displacement. Displacement from initial position to final position, but displacement is the whole distance that travel. For example, if I have a B, and this bee is flying like this. Okay, now it covers a lot of distance. Okay, it covers a huge distance, but the displacement of it, if it start and finish at the same position, how much it is, Shahad? Exactly. Thank you, Yusuf. It is zero. Why? Because it started and finished at approximately the same position. So that means there is no displacement here. So that means if they ask about velocity here, the velocity of the bee is 0. But if they ask about the speed, it has an average speed, which is a huge value, not only 0. Okay, good. Is it clear now, Shahid? Did you understand it? Anytime, if you have any question, you can send me on the chat. I can read it and tell me. You are welcome. Okay, another thing that we have to unit in physics, that we have something called base or fundamental quantities and units. And these are 6, okay, 7 actually, but 6 in the old syllabus, in the new syllabus, there are 7, okay, 7 different quantities that they are the basic in physics, okay, which they are the time, the mass, the length, the current, okay. These 3, the first 3, the time, mass, and current, they will ask about it in unit 1. Usually, they will ask about it in unit 1. Okay, the current, okay, they ask about it in unit 2 with the previous ones. Okay, temperature, amount of substance, light luminosity, they will ask about it in A2 physics in unit 4 and unit 5. Okay, so the first 4 things, they are okay quantities, they are included in our syllabus for this year as AS. The first 3, time, mass, and length, only for the unit 1. The time in seconds, the mass in kilograms, and the length in what? In meters. Okay, so if we don't have base unit, like what? Like speed. Speed, it doesn't have base unit because its unit, it's meters per second. It's not single unit. And the same thing for acceleration. Acceleration, it's meters per second, so meters per second square. So these are the fundamental quantities, okay, that they are based on everything in physics, and everything like depends on it. For example, speed equal distance divided by time. If we are talking about something else, you are going to see later on that all these details depends on it. Now, for example, here we have other units we call drive units. Like, what is the unit of force? Who can tell me what's the unit of force? Send me on the chat. What is the unit of force? Exactly. What's the unit of force? Bravo, Newton, capital N. The unit of force is a Newton. And actually, before they write in Newton, they were write huge things like base quantities. They derive it from the Newton. Okay. So what is the Newton actually? We know that force equal mass multiplied by what? Acceleration. And the force that we just say that it's a Newton equal the mass, which is in kilograms, multiplied by what acceleration, that's its meters per second square. So in Newton, instead of writing in Newton, there was writing kilogram dot meter per second square. How do they bring questions like this? They bring questions like this as multiple choice question, okay, or 1 mark, okay, question, okay, in the parts, okay, or sometimes they bring it as 2 or 3 marks to drive the unit or find out the base unit of each of the following. Sometimes they give you a new example, a new phenomena, a new situation, even a new equation, and they ask from you to find the value of lambda, or to find the value of k, or to find what is the unit or the base unit of some constant like Stephen Boltzmann constant or kinetic energy of gas molecules. We don't know these stuff. We are not going to study it in unit 1 AS physics. Okay, maybe you don't even study hear about it even in the university. They give you the equation and they will ask about you. They ask you to drive the unit of it, and that's what we are going to study during this course, inshallah, in the future. Another thing like joule, the unit of work is what, ya shabab? What's the unit of work? Is joule. Every time I talk about work and joule, yes, thank you, Noor, and to Yusuf. Okay, I remember one of the good stories that I had it 20 years ago in my life. I had a student that every time that he want to make a relationship between what he studied and what is the unit of it, because he forgot the unit. So every time I create a new thing for him, and once he didn't he can't memorize, okay, what was the unit of work or energy, which is joule. I asked him, what is your favorite player, soccer player or football player? And that time there was a person called Roberto Carlos. I don't know if all of you know him. 20 years ago, maybe you don't know him. Okay, Roberto Carlos. I asked him, why did you like Roberto Carlos? He told me because he's a good player, لعيب يعني بيعرف يلعب وأموره تمام. What? I asked him what else? Because he made goals, great goals. In that year, a couple of years ago, a couple of years before that, he was making a famous goal on France on World Cup. So I asked him to go on the board, okay, and write the word goal. And he write it like this in Arabic, June. I said, okay, that's good. So since Roberto Carlos, he's a good player, okay, he has energy to kick the ball, which make a goal and which is June, صح? Right? So he understand it, he memorized it, and after that, by a couple of days, there was a quiz, and the first question of the quiz, okay, what is the unit of work? Imagine what did he write? What's the unit of work? What's the unit of work? Okay, according to my story, okay, for this student, okay, he didn't write Joule. He didn't write like this. And he didn't write Joule. Yes, he didn't write Joule. No, thank you, Ayat. No, he didn't. No, thank you. No, no. Hey, Heba, no. He wrote Roberto Carlos. He wrote Roberto Carlos. Yes. Okay. So the unit of joule, as we know, it's work, which is equal force multiplied by what? Distance. So that means, yes, Yusuf, it's funny. Yes, Ayat, yes. The unit of work, which is joule, is the unit of force that we just find it out here, okay, which is kilogram dot meter per second square, multiplied by the unit of distance, which is meter. So that means the unit of work, it's equal to kilogram dot meter square per second what square. This is the unit of work and the unit of energy, okay, before they could change it from being kilogram dot meter square per second square to joule, okay. Another thing, another example, okay, for how we can convert these is the unit of what? Of pressure. And we know that pressure, the unit of it is what? PA, yes, Pascal, capital P, small a, because it's the name of Louis Pascal, okay, a French scientist. Okay, now we know that pressure is the defined as the force act per unit area. So it's the force divided by what? Area. And that means the force, which we wrote it before, kilogram dot meter per second square divided by what? The area, which is in meter square. So if we move the meter square upward, it will be -2. So meter here to the power of -1, a positive 1, and meter to the power of -2, that means it will be kilogram dot per meter dot per second square. All this is Pascal, okay? So these are drive units that actually come out from base unit, fundamental units, okay? One of the questions that they can ask about it is from unit 2, okay, this is unit 2, is potential difference. Who can remind me what's the definition of potential difference from what you remember from the IGCSE? Or what is the formula for potential difference or voltage, PD, the voltage? What's the formula for it? Yes, thank you, Hiba. Okay, who else? Thank you, Muhammad. Okay, it's the amount of energy given per unit of what? Of charge. So energy, we're talking about what here? We're talking about joule, right? And charge, we are talking about coulombs. So this is joule per what? Coulomb. And we know that joule, we just find it out here, which is what? Kilogram dot meter square per second square. And charge, we know that charge equal current multiplied by time. So coulomb is ampere multiplied by second. So we can put it here, okay, ampere dot second, okay. And as we know, if we move these to make it in the top here, it will be to the power of negative. That means it will be kilogram dot meter square per ampere per second cube. All of this is the same as what? As voltage, the unit of potential difference, which is volt, according to Alexandre Volta. So Do they bring questions about these? Yes, every year they bring at least one mark question, okay, as multiple choice or as a written part question, part B or part C of question number 12 or 13, depends on the year, or they ask to find out or drive the unit of this quantity, okay, or something we are going to study it later on about something called homogeneous equations. Now we heard about homogeneous in math and in chemistry, but sorry, in bio and chemistry. And in bio and chemistry, homogeneous, that means the solution that has same concentration, okay, in any part of it. Now, homogeneous equation that we are going to study it later on, okay, means that this equation, both of the right and left side equation of any equation in physics, they have what? Same unit. They have to have same unit, okay? Kinetic energy and potential energy, they have the same unit as joule, as work. Okay, Lama, I'll show you. For example, the kinetic energy, which is joule, okay? It's equal to half mv squared. Now, kinetic energy that we just said, it is joule, it's equal to half, its constant value doesn't have unit, multiplied by the mass, which is in kilogram, multiplied by the velocity or the speed, which is meter per second square. So that means I'll open the bracket, so it will be kilogram per meter square, sorry, kilogram dot meter square per second square, which is the same as this one, okay? And the same thing as potential energy, elastic energy, chemical energy, whatever, even the energy that we use it in heat or specific heat capacity or something like this, okay? Because all the energies, they have the same unit as work, which is joule or Roberto Carlos, okay? طيب, good. Okay. Another thing that we have to know it, okay, before we talk about any lesson, is something that called prefixes, okay? What is the prefixes? They are used as small letters to tell us how big or small is the value, okay? Now, we know that we heard in computers or mobiles that we have something called kilopixel, megapixel, okay, gigapixel or gigagram, okay, or in computer or mobile or communication technology speed, okay? All these units, how big or fast is the unit? The same thing for tera. Now, kilo is 1,000 and mega is 1,000,000. Giga is 1,000,000,000 and mega is 1,000 billion, okay? Or mega, sorry, a million, okay? So you can write this as like this, 10 to the power, okay, multiplied by 10 to the power. How many zeros do we have here? We have 12 zeros. And as you can see here, the values of the number is multiply of 10, okay? 3, increase by 3 or decrease by 3, as we are going to see now, okay? Times 10 to the power of 9, okay? This is giga. Mega means million times 10 to the power of 6, okay? Kilo means times 10 to the power of 3, okay? The only thing which is new here, okay, it's centimeter, centigram, centisecond. Centi came from cent. How many cents do we have in $1? How many cents do we have in $1? Exactly, we have 100 cents. Exactly. Okay, so thank you. Thank you, Hiba. Thank you, Hamad. So we have 100 cents. So to convert from centimeter to meter, we need to divide by what? Divide by 100. Divide by 100. That means, okay, multiply it by 10 to the power of negative what? Negative 2. And the word milli means 1,000th. That means a part of 1,000. That means I'll multiply it by 10 to the power of negative 3. And micro, which is very small value that we are going to use it usually in biology, which is times 10 to the power of negative what 6, which is very small thing. Micrometer things, that means we cannot see it as a human being, okay? Like microscope. Nano came from word 9. That means times 10 to the power of negative 9 times 10 to the power of negative 9, and pico times 10 to the power of negative 12. These are the main prefixes that they ask about it, and the letters for them, they are tera, capital T, giga, mega, and kilo, centicent, okay, milli, okay, micro, Greek letter like this one, and nano, small n, okay, and pico, small p, okay? These are the prefixes, and we have to know how to convert any value that they give it to us to the base unit, okay? We are not going to keep it in, for example, terajoule. Terajoule, we are going to write it down as 1 terajoule means 1 times 10 to the power of 12 joule, etc. Okay? We have to know how to convert these values, okay? Okay. Now, let's see the first question. Which of the units is the same as in Newton? Who can send me the answer? Send me on the chat. Which one of these is the same as, yes, in Newton? Which one of these? Go up? Okay, I'll go up now. Which one of these is Newton? Yeah, send me on the chat. Which one of these is Newton? This is Newton. Which one of these is Newton? Kilogram dot meter per second square. So kilogram dot meter per second square, which is what? Which is B. Good? Clear? Okay. Another question. Question number 2. Which one of the following, okay, which set of quantities are all scalar? Yes, who can tell me which one is the correct answer? All of them, they are scalar. Yes. Yes, who can tell me? Bravo, Omar. Bravo, Lama. Laith, Yusuf, Lana. Okay. Yes, you can see that the correct answer is what is B, energy, mass, and power. Because here, if we look to acceleration and displacement and velocity, all of these, they are vector, they have direction. Okay. If you look to the force and gravity, okay, it has direction. If you look to the weight, it has direction. So these in B, part B, the answer, okay, energy, mass, and power, all of these, they don't have direction. Okay, next question. Which of the following is not a vector quantity? Displacement, force, weight, exactly. Thank you, Omar. Thank you, Yusuf. Thank you, Lana. The correct answer is what? D. The work is not a vector quantity, etc. Okay, now this is a hard one. Question number 4. Which one of the following unit is equivalent to the SI unit of energy? SI unit, all the base and quantities that we study it here, they called SI unit, standard international units and quantities. So who can tell me which one of the following units is equivalent to the SI unit for energy? It's similar to joule. Which one of these? Who can tell me? Thank you, Omar. Thank you, Lama. Lama, check your answer if you please. Okay. Thank you, Shahid. Also, you check your answer if you please. Now, most of you said that the answer is A, which is kilogram dot meter per second square. Actually, joule is kilogram dot meter square per watt second square. But so the answer is not A. The answer is not A. Which one is equivalent to joule? Now, yes, kilowatt dot hour, it's a unit of energy, but it's not joule. Kilowatt dot hour is 3,600 joules, so it's not joule. Okay, we are going to study it later. The answer is watt dot second, because we know that power is what? Energy divided by time. If we do cross multiplication, that means energy is power times time, and the unit of power is watt, and the unit of time is what? Is seconds. So the correct answer here is what? Yes, it's D. Okay, let's move on. Question number 5. Who can tell me which one is the correct answer in number 5? Yes, the table shows some physical quantities which row correctly I define scalar and vector quantity. Scalar. It is distance is a scalar. Time is a scalar. Work is a scalar. Okay, velocity, vector. Acceleration is vector. Force is a vector. So which one is the correct answer? Yes, exactly. It's the answer. A, part A. Yes, thank you, Yusuf. Good. Okay, now let's go on to talk about mechanics and motion, and you know about it a lot since the 9th grade and before that from the IGCSE or maybe from 8th grade. I know that some of the science books, okay, in our huge Arab countries, we have it in from third grade or fourth grade. They talk about motion and speed. So if we know, if you want to find what's the meaning of speed, what's the definition of speed? Who can see me on the chat? What is the definition of speed? Yes, what is the definition of speed? Exactly, thank you. It's distance covered per unit of time. Per unit of time. Or you can say the rate of covering distance, yes. But if I want to talk about velocity here, what's the velocity? Exactly, it's not distance covered per time, it's displacement. Exactly, displacement covered what? Per time, per unit of time. And if you know here, okay, now we have a very famous formula that most of the students know it, that speed equal distance over time. And I know that a lot of students, they memorize it like this: distance equals speed times time, like this, the triangle. Okay, now, okay, it's good to memorize this one, but we're not going to use it a lot, okay? And now on, we are going to use the A-level symbols, okay, which is velocity equal what? Distance or displacement. They use it letter S to represent it. Divide by what? Divide by time. So now on, we're going to use this formula, okay? Not S equal D over T, okay? V equal distance, or S, divided by T time. Now, who can tell me what is the unit of this distance or displacement? What the unit of distance or displacement can be? Yes, send me on the chat. Thank you, Lama. Thank you, Noor. What's the unit of the unit of distance? This is distance, okay? Yes, it can be meters, or it can be what? Kilometers. Bravo. And what's the unit of time here? It can be seconds, or it can be what? Hours. So what will be the unit of speed or velocity? It can be what? Bravo. It can be meters per second, or what? Kilometers per hour. So meters per second, or what? Kilometers per what? Per hour. Now, who can tell which one is bigger? Is meters per second as unit bigger, or kilometer per hour is bigger? Send me on the chat. Is meter per second, for example, I'm driving my car at 100 meters per second is faster, or 100 kilometer per hour is faster, or both are the same? Some of you send me meters per second, some of you send me meters kilometer per hour, some of you send me both are the same. Okay, now I want from you to bring out your calculators, okay? I want from, yes, all of you, bring out your calculators. And I want from you to try to convert 1 meters per second to what? To kilometer per what? Hour. Now, we know that from the IGCSE that each 1 meter, if I want to convert it into kilometers, we will divide by how much? Exactly, we divide by 1,000. Each kilometer is 1,000 meters. So from meter to kilometer, we divide by 1,000. And how many hours? Every second, every hour, how many seconds? Exactly, 60 minutes multiplied by 60 seconds. And 60 times 60 is not 120. It's not 360. It's 3,600. Thank you, Lama. Thank you, Muhammad. So we divided by how much? 1 divided by 3,600. If you use the calculator and you put fraction 1 divided by 1,000 over 1 divided by 3,600, how much did you get? Exactly. You got how much? Another answer? Excellent, Muhammad. Third answer from Hiba. Bravo. It's 3.6. What that means? What that means, or 18 over 5. Yes, what that means? That means meters per second. Each 1 meters per second, it's equal to what? 3.6 kilometer per hour. That means that means meters per second is bigger than kilometer per hour by 3.6 times. Okay, Do you want to check that? Okay, let's do this question. And why we are doing it, we are going to check what is the correct way to understand this. Okay, let's move on. Question number 1. Okay, a car covers 36 kilometers in half hour. A car covers 36 kilometers in half hour. They give us the distance or the displacement, and they give us what? The time. Okay, so find out the car something speed. What is the word that I have to write it here to make this correct example or correct question? Look, they ask about speed, they didn't ask about velocity. So what is the word here that I have to write it down? Okay, send me on the chat. Thank you, Noor. Excellent, correct answer. And why they use the word speed, not velocity? Yes, they use the word speed, not velocity, because we didn't know the direction. Maybe 36 kilometers, maybe they changed their directions. It's a long distance. So the word here, what's the car average? Bravo. Average speed in part A, kilometer per hour, part B, what? Meters per second. So let's do it for part A in kilometer per hour. We know that velocity or speed equal distance over time, which is equal 36. Thank you, Yusuf. Divide by the time, which is half or 0.5. And the answer it will be 72 kilometer per hour. Since now on, we are not going to write kilometer slash hour. We are going to write kilometer dot hour negative 1. Okay, so we are not going to use this one. We are not IGs anymore. We are A level. Okay, for next part here, we need to find the speed. So speed, okay, or it's in meters per second. We know that it's equal distance divided by time, and it's 36 kilometer divided by what? Half hour. And we need to convert this from being in kilometer to meter multiplied by 1,000, and from being in hours into seconds by multiplied by 3,600. And by using the calculator, our answer, it will be how much? 20 meters per second. Thank you, Yusuf. Yes, correct. Right. Now my question. Which one is bigger? Which one is bigger? Is 20 meters per second bigger, or 72 kilometers per hour is bigger? The time is half hour. 0.5 is half. Or you can write it 1/2. Okay. Now, which one is bigger? 72 kilometers per hour or 20 meters per second? Send me on the chat. Which one is bigger? 72 kilometers per hour or 20 meters per second? Thank you, Yusuf. Excellent. Which one is bigger? Exactly. Thank you, Yusuf. Thank you, Muhammad. They are the same. We're talking about the same car, but different units. 72 kilometers per hour. It is 20 meters per second. We are talking about the same thing here. Okay. So yes, this is one question. Now let's do a past paper question. This is past paper question, and every question that I bring it, I will show you from which year. Okay, this is May, June 2009, question number 11, the first question after the multiple choice questions. Okay, what do we have here? A, explain the difference between scalar and vector quantities. It's very easy. We can bring an IGCSE student who talk physics and can answer this question. We can say that scalar has no have no direction, since we are talking about quantities, have no direction. Bravo, thank you, Lema. While vector have direction. Vector quantities have direction. So the difference here is the direction. And if we write only in the exam the word direction, we are not going to get the mark because they ask us to explain. Okay, لا تكون بخيل معهم لأن هم حيكونوا بخيلين معك في العلامة. So you have to write the whole answer. Okay, ماشي. Okay, part B. When asked to run one complete lap, okay, around a track, okay, I need to run, okay, and I finish one complete lap around a track. The student says, however fast I ran, okay, my average velocity For the lab, it will be 0. Comment on his statement. Thank you, Yusuf. I'll read it later. Okay, thank you. Another answer, a third answer, a fourth answer. Why the average velocity here is 0? Excellent, bravo. If we have a complete lab here, that means I will start and finish at the same point as we talk about the bee, okay, or about the fly. So that because since the starting and the finishing point is the same, that means there's no displacement here. So when there's no displacement, there is no what? Velocity. So since he started and finished at the same point, so his displacement is 0. And since velocity and since velocity is the rate of covering displacement, so his velocity is 0. That's good. Amazing. Thank you, Lama. Thank you, Yusuf. Your answers are good. This is past paper question. Tamam. Let's move on. Okay. Let's go to another word that we heard about it a lot in the IGCSE, what we call it acceleration. What's the meaning of acceleration? Send me on the chat. What's the meaning? Yes, thank you. What's the meaning of acceleration? Another one. 5 words. Yes. The rate of changing, not speed. The rate, divide by second, or every second, the rate of changing velocity. Yes, exactly. So while we are changing velocity, there is acceleration, the rate of changing what? Velocity. So as the velocity is changed, there is what? Acceleration, the changing velocity. Okay. Why we use the word velocity, not speed? Because we know that acceleration has 3 meanings. Okay. What is the 3 meanings? What are the 3 meanings? Okay. Speeding up. Bravo. What else? Who can tell me? What are the 3 meanings? Speeding up. What else? Good. Slowing down. Excellent. What else? So we have speeding up, slowing down, and finally that's why. Yes. تفضل هنون or Hanoun. Yes.
If you're saying here that the acceleration is speeding up, while speed is a scalar quantity, it does not have a direction. Why are you saying speeding up?
Now the ratio of now the word in English called speeding up, but that doesn't mean that the velocity doesn't increase, and it increases in the same direction since it is linear. Now you understand when I say the third word here. What's the third word? Changing what? Changing direction. Changing direction. Direction of motion. So when there's speeding up, that means there's positive acceleration. And when it's slowing down, can you put yourself on mute? Thank you, Hanoun. Okay, and when it's slowing down, that means it's negative. And what we call it here? Thank you, Noor. Thank you, Shahad. We call it deceleration or retardation. Okay, and the last topic here. Okay, we are going to ask about it in curved motion. And curved motion, actually, they don't ask about it in AS. They ask about it in A2. But that's what you are going to study it later on, inshallah. So The rate of changing velocity, that means acceleration equal, as we know, v minus u over what? Over t. This is the formula that you studied in the IGCSE ninth grade, okay, or any year. That depends on the curriculum or the syllabus that you are studying or the school, okay. So now on, we are going to talk about something called uniform linear motion in a straight line in a certain direction. Actually, we are going, after we finish this, okay, maybe 2 classes from now, we are going to talk about the whole motion, not only linear, not about the uniform, maybe the non-uniform motion. So we're going to talk about all the details, and we are going to draw a great mind map. So when we talk about uniform linear motion, we are talking about 2 different situations here. What are the 2 different situations? We are talking about the uniform acceleration. Okay, later on we are going to talk on the non-uniform acceleration, uniform acceleration, okay, and steady what? Steady velocity, steady speed or steady velocity. I said steady velocity because we are talking about straight line, certain direction. So steady what? Velocity. Now, what's the opposite of motion? The opposite of motion, it's what? What's the opposite of it? Exactly, stationary. That means the object is what? Ya salam, ya salam, bravo. That means the object is what? Is at rest, doesn't move. Now, any object at rest or a steady velocity together, these 2 different situations, what they call them? What do they call these 2 different situations? Bravo, they call it balanced object. They call it what? Balanced object. And we are going to talk about that when we talk about forces later on, according to Newton's first law of motion. So any object at uniform acceleration or constant speed or constant velocity, I will not use the formula here instead of there, or there instead of here. Here we are going to use only one formula: velocity or speed equal distance or displacement divided by time. This is the only formula that we are going to use it. Okay? But be careful. But if we talk about the acceleration, this is the old formula, and there's other formula that for Edexcel and Oxford, they know it, okay? According to something called SOVAT. SOVAT. What are the SOVAT? S is the displacement, U is the initial speed, V is the final speed, A is the acceleration, and T is the time. As you can see, we have 5 different variables in uniform acceleration, not as in steady velocity. We have only 3, because here we have acceleration. That means there is change in velocity. Here we don't have change in velocity. So I can't use this formula when there is acceleration. So what are the equations that we have it when there is uniform speed? There we have actually 5 different formulas. 3 of them, they will give it to you for Edexcel in the answer formula sheet at the last page of the exam. Okay, it's the rearrange of this formula. Velocity equal u initial velocity plus acceleration times time. This is the first equation. Second equation, final velocity square equal initial velocity square plus 2 acceleration multiplied by distance or displacement. Third equation, okay, displacement equal ut plus half a t squared. These are the main 3 formulas that they ask about it in the exams. Sometimes they ask about the last 2 equations that they are not, you don't have them, okay, which is displacement equal final velocity multiplied by time, vt, plus half acceleration t squared, and the last equation here, which is what? Displacement equal average speed, which is u plus v over 2, multiplied by what? Multiplied by time. Now, I know that most of you know these equations, Okay, these 5 equations according to something called SOVAT. Maybe you heard about it in mechanics M1, or maybe you are taking Edexcel IGCSE physics, so you heard about 3 of these equations. But if you look here, each equation has 4 variables: u, v, u, a, t, v square, u, a, distance or displacement, s equal u time acceleration. So that means there's, in any question they give you to you, at least they have to give you 3 givens, and they ask about the 4th, maybe the 5th one. Okay, so as you can see here also, in this equation we don't have what? Distance or displacement. So this is called no displacement equation. The second equation, we don't have time, they call it no time equation. The third equation, no v equation, I don't have final velocity here. Here I don't have initial velocity, and the last one, I don't have what? Acceleration. Okay. So in any question they give it to us, they have to give us 3 information if they are talking about single body, single object. And sometimes these information are hidden. What do I mean by hidden equation? We are going to see now. Okay. So this is the mind map for the beginning. Okay. We know that we have Newton's first law. Okay. Newton's first law that talks about balanced object. We are going to study it later on. Newton's first law of motion that says that resultant force equals 0. And here these, okay, unbalanced object, they are talking about Newton second law of motion. We are going to talk about it later on. As we know that resultant force equal what? Equal mass times acceleration. Okay, we're going to talk about these later with more details. This mind map will get bigger and bigger until it complete the whole topic that we're going to study it. Okay, good. Okay, let's move on to example number 2 here. What do we have? Look, a car accelerates uniformly from 10 to 20 meters per second in 5 seconds. This is easy. 10 is the initial speed, and v is 20, and t is the time. Find out. Look, I told you, they give you 3 information, 3 given, u, v, t, and they ask about what? About the 4th or the 5th. Okay, they ask about the acceleration. Thank you, Lama. The acceleration here, you can write the formula v minus u over t, or you can write the first equation v equal u plus at and rearrange to find out what the acceleration. It will be the same thing. So 20 minus 10 divided by what? Divide by 5, and the answer, it will be how much? 20 minus 10 is 10 divided by 5, it will be 2. What's my mistake? I did a mistake here. I didn't get my mark. I didn't get full mark here. What's my mistake? Who can tell me? What's my mistake? Usually, sometimes in Edexcel or even Cambridge, okay, the final answer is supposed to be 2 or 3 significant figures. 2 or 3 significant figures. So this is 2.0, okay, and also I forgot to write the unit, which is what? Meters per second squared. So if I didn't write the answer 2 or 3 significant figures and I didn't write the unit, I lose the mark. Yes, we have to write the unit. Okay, yes, it's not like Edexcel IGCSE. Edexcel IGCSE, they give you the unit. Now it's not. Okay. Part B, what do they ask? The distance covered during the first 5 seconds. Now, as you can see, I only have u, v, t, and they ask about the distance. That means I will use no A equation because I have u, v, t, and they ask about the distance, s, or the displacement. That means I don't have the acceleration, so I use this equation, s equal u plus v over 2 multiplied by t, which is equal 10 plus 20, 30 divided by 2, 15 multiplied by 5, which is equal to how much? 15 times 5, 75 what? Meters. Good? Clear? Any question? Okay. Sometimes They give you, as I told you, a hidden information. Sometimes the hidden information it's clear, other times it's not. A bus accelerates uniformly at a rate of 2 meters per second. This is the acceleration. From rest for how long? What? 4 seconds. So they give us the acceleration and they give us the time. What is the hidden information here? What's the information which is hidden and we know it, you know it, and I can use it to answer any question here. Find out the speed at the end. That means they ask about final speed, V equal, okay? And find the distance covered, S equal. Who can tell me what is the hidden information that's written in the equation and we know it? Exactly, from rest. From rest, that means U is equal to what? To 0. So that means I will use the equation V equal U plus 80. And from rest, that means U equals 0 plus the acceleration, which is 2, multiplied by the time, which is 4. And my answer, it will be 8. Again, I will not leave it as 8. I'll write the 0.0. And also, I'll write the unit, which is meter per second. Next part here, what do we have? The distance covered. I know the acceleration, the initial speed, the time, and they ask about the distance. So I will use no V equation, the third equation, S equal what? S equal UT plus half AT squared. And as you can see, U, which is 0, multiplied by anything is 0, plus half multiplied by 2, which is 1, multiplied by the time, which is 4 squared, and the answer it will be 16 meters. Good? Clear? Yes, it is clear. It is easy. Okay, let's move on to this part. Question number 4. In question number 4, okay, a stone is dropped from the top of a building and hits the ground in 3.2 seconds. How many given do we have here? In this line, how many given do we have? A stone is dropped from the top of building, and hits the ground in 3.2 seconds. Yes, what's the answer here? We have 3 given. The time, the word dropped means they give us the initial speed, which is 0, and also they give us the acceleration. How much is the acceleration when you drop any object? How much is the acceleration when you drop any object? Yes, how much is the acceleration when you release any object? It falls down. How much is the acceleration here on Earth? Exactly. It is 9.81. That means on Earth, the acceleration, it will be approximately 9.81 meters per second squared. That means every object we release it here, it will fall with 9.81 meters per second squared. Not 10, not 9.8, 9.81 meters per second squared. This is the acceleration of free fall here on Earth, and it changes according to the gravitational field strength on each planet. Okay, we are going to talk about it in details. Okay, what do we have here? A, the speed of impact with the ground. They ask about what? They ask about the final speed. So that means V, the final speed, equal U, which is 0, plus the acceleration, which is 9.81, multiplied by what? The time. So by using calculator, how much is the answer? Who has a calculator? Yes, it will be approximately how much? It will be approximately 30. Okay, now I'm not going to write the whole answer. I'm not going to write down the whole thing. 3T1.392. No. I'm not going to write. I'm going to write it in 2 different ways. I go to write it down as 31 meters per second or 31.4. Why 4? The 9 rounded up. So I'm going to write it as 2 or 3 significant figures. So this is the speed of impact with what? With the ground. The height of the building. When they ask about the height of the building, they ask about what? Excellent. They ask about the displacement here. How high or the distance that it falls. And we know that all objects they fall with the same acceleration, assuming that there is no air resistance. That's why they use the word stone. Stone, it will not be affected by air resistance unless it reach a very high speed. Okay, So if I know U, I know A, I know T, and they ask about S, so I'm going to use the formula S is equal to UT plus half AT squared, which is equal to 0 plus half times 9.81 multiplied by the time, which is 3.2 squared, and by using calculator, 9.81 times 3.2 squared, the answer, it will be how much? The answer, it will be 100 meter, yes. Yes, you can write it 100, okay, or it is 100, I know it's 100.4544 by using calculator. But I'm not going to write the whole things. It's 2 or 3 significant figures. The 4 cannot make it 101, okay? Good. Any question? Okay, a question from past paper here. Let's see it. What is meant by vector quantity? This is from May 2011, question number 11. What is meant by vector quantity? Okay, the quantity which has what? Magnitude, bravo, and unit with direction. Magnitude with unit and direction. Good. And direction. So this is one easy mark. You can get it out from the externals. Okay, we need to collect all the marks from the external to get A, inshallah, or high A. Yeah, you know that about 54 out of 80 it's A. Sometimes 56 out of 80 it's A. So other times it's 49 out of 80 it's A. So it is not easy to get the A, but okay, but inshallah with me you are going to get the A, inshallah. So part B, a car is driven around a bend at constant speed. A bend at constant speed. Explain what happens to its velocity. Who can tell me what happened to its velocity? The velocity remains constant or increases or decreases, or what do you think? Yeah, send me on the chat. Thank you, Hannoun. Thank you, Lama. Thank you, Muhammad. Changes. Why changes? Why it's not necessary to be constant, because here we have a bend. That means the direction changes. If this is the bend, okay, that means the car was moving at this speed, then the speed remains constant, but it changed in this direction now. So we know that as the direction changes, that means the velocity changes, right? So exactly, the answer changes due to the change in direction. Changes due to the change in direction. Okay. Velocity change going positive or negative? Yes, we have positive direction and negative direction, as we are going to study later on in momentum, or we talk about the resultant force. Yes, and direction. Okay. Any other questions? Is it clear? Okay. Now, if you want to check, this is the mark scheme. Okay. Let me show you here what they ask: magnet and direction. For magnet, accept size but not value measured. Okay. Example given that but not accept definition applied. That means it changes what? Its direction. Direction changes, not a straight line. Velocity changes, not constant. Due with what? Change in direction. Tamam? Okay. Let's move on to question number 8. Bring out your calculators and try to find out the answer for the first question 8. A cyclist traveling at a speed of 4.2 meters per second accelerates at 1.1. So this is U. This is the acceleration, 1.1 meters per second square. In time of 7.4 seconds, the distance traveled is, yes, what is the distance? Which formula I'm going to use here? They ask about the distance. Which formula I'm going to use? The distance, the formula that doesn't have V. Which formula that doesn't have V? No V equation. Yes. S equal UT plus half AT squared. Now, I know that this equation is written in the back of the booklet of the exam, but I want from you to memorize them because you don't have time to keep going to the back of the booklet. Okay, it's very fast. Okay, we have 1 hour, 30 minutes. Okay, approximately each question, each mark less than 1 minute and 15 seconds to answer. So if like this question is a multiple choice question, okay, maybe it take from some of you more than a minute to answer. So that's why I prefer, as I'm always saying, my advice to my students, do not start with a multiple choice question during the exam. Start with the first question after the multiple choice question, which is question number 11. Do not waste your time in the multiple choice questions. Go directly to question number 11, and after you finish, you can go to the multiple choice questions. Okay, so U, which is 4.2 times the time, which is 7.2, plus half multiplied by the acceleration, which is 1.1, multiplied by the time, which is 7.2 squared. And by using calculator, the answer is approximately 60 something. Yes, it is 61. So the answer is what? Is C. Thank you, Lema. Good. Okay. Now, I want from you to try to do the other questions as homework, okay? Later on, we are going to answer it, okay? These are the questions I want from you to try to do it homework. Next class, we are going to answer it. Let's move on to question number 14, okay? In question number 14, page number 8. Question number 14, page number 8. What do we have? A trolley moves down at around from rest. So that means this is the initial speed, which is what, 0, okay? Attached to a trolley, okay, to the trolley in a strip of paper, which is pulled through a ticker tape timer. The timer times 50 dots each second. That means the period, the time for each dot, okay, is the time divided by number of dots. So that means 1 second divided by 50. So each dot needs 0.02 seconds to happen. Okay, this ticker tape keep dotting faster than my hand. Okay, 50 dots every second. So that sticker tape they was using it to describe the motion. Let me explain what do we mean. For example, if the ticker tape, the distance between them like this, same distance between each tick and the other, each dot and the other, that means the distance covered is the same, so that means it's moving at constant speed. But as the distance is going to get farther and farther, that means the object is moving with what? With increasing speed, okay? That means acceleration. But if the object has a distance that was far from each other and they get close to each other, that means the speed what? Decreases, etc. So this ticker tape, they was using it before they was using camera and digital camera and motion sensors to describe the motion, to do experiments. Okay, we're going to explain that later on in details. So this is the ticker tape and this is the tape, okay, that attached to the trolley, and the trolley moves. The strip of paper is shown below, okay. The start and the end of the journey are indicated, okay. This is the start. You can see that the dots are close from each other. At the end, they are far from each other. Using measurements from the tape show that the final velocity of the trolley is about 1 meters per second. Now, whenever they give us a value and they ask to show, that means this value, I'm going to use it in next part, even if I don't know how to answer it. So every time they ask you to show, okay, that means I'm going to use this answer. If I don't know how to get this answer, my answer is supposed to be 1, are we going to use it in next part, or maybe not directly next part, later on? Okay, and when they ask you to use what measurements, that means I can use my protractor, my ruler, okay, to find out the distance. Who can measure the distance from here to here and tell me how much it is? How much is the distance between the center of this dot to the center of the next dot, because we are talking about the final speed? Use your ruler. I know that you have different printers, okay, and maybe you've printed out different scale, but approximately the distance is approximately, yes, thank you, Muhammad. It's approximately 2.2 what? Centimeter, right? Good. So that means if I want to find the final velocity in this situation, what I'm going to say here, I'm going to say that the final velocity, okay, is equal to the distance, okay, in this moment divided by time. And the distance, which is 2.2 centimeter, which is 0.022 in meter, okay, I have to convert it from centimeter to meter, from millimeter to meter, whatever, divided by the time, and the time for each, the time interval between dot and the next dot, as we said here, it makes 50 dots every second. That means the time for each dot to the next one is 0.02, 0.02. So by using calculator, that means the answer, it will be approximately 1.1 meters per second. This is very easy question, 2 marks on it. If I don't know how to get this answer, I will use my value that they give it to us later on in next part. So that's why, what do they ask next part? Hence, calculate the average acceleration of the trolley. Now we know that acceleration equal what? V minus U divided by T. And V that we just find it out, which is 1.1, okay, divided, okay, minus the initial speed, which is 0. It is from rest here, we say that it's 0, divided by the time. How long is the time? Is it 2.2? No, it's not 2.2 by itself. It is 2.2, but 2.2 multiplied by how many time intervals? We have one time interval. I will not count the first dot. The first dot, that means it starts from 0. That means 0.02, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 time intervals. That means I'm going to use 13 time intervals, which each time interval is 0.02. So that means 0.02 multiplied by what? By 13. And by using the calculator, I would say that 1.1 divided by 2.2 multiplied by, I'm sorry, 0.02. Okay, here. I'm sorry. 0.02. 0.02. Okay. 0.02 multiplied by 13. And the answer, it will be how much? 4.2307. I'm not going to write all this. I'm going to write 4.2 or 4.23 meters per second square. That's it. Okay. Tamam. Clear? Good. Okay. This is part A and B of the question. If we go to part, okay, B, part A, I, double I. If we go to part B, what do you say? Using a ticker tape timer is one method of measuring the speed of a moving object in a laboratory. Another method is to use a light gate, as we are going to explain later on, with a data logger, okay, that give the information to put it with the timer. And sometimes they use it to connect it with a computer, so the computer can make calculations, can draw a graph directly, okay? So just an advantage of using light gate method rather than using a ticker tape timer. What do you think? Tell me on the chat. What is the advantage of the new ICT technology, okay, to find out or describe the motion rather than by using what? The ticker tape. I can't say only the word more accurate. I can't say that. I can say it more precise, okay? I have to mention an advantage that makes it more precise, that makes it more accurate. I need to compare between that and this as an advantage. Or you can say a disadvantage of the ticker tape timer. Okay, using light gate will be more accurate because the light is, I can't say that, it's very fast. No, I can't say it. I'm reading your answers. No, I can't say this. No. Another answer. Okay. Now we didn't study this, how ICT, how we can use computer and data logger. I didn't explain it later on in the next classes. We are going to explain it from while to while. But look here, what do they write in the mark scheme? Look, they say that you can say there's no friction, no drag between tape or the timer or the trolley with the timer or whatever. Okay, the computer does the calculation. This is the advantages. Okay, or student doesn't calculate velocity. Okay, he didn't make the calculation by the velocity, the final velocity. He will not do that, what we did. He will not do that. The student, if he use a data logger with a light gate and connect to computer, he will not do anything like this. So look here what they said. Do not write precise, accurate, plot a graph automatically. Reaction time is negligible. Parallax error, human error is negligible. It's not allowed, okay, in this situation. So we have to be more precise by answering these type of questions. So what we're going to say, the ticker tape causes friction, affect the motion, and the computer does the calculation not the student. The calculations, not the student. Okay, tamam, clear? Okay, let's move on to the next question. Here in this question, what do we have? This is a star question. Star question in the old syllabus, they was bring it for the 3, 4, 5, 6 mark question, okay? And it's not like the new way how we can calculate, how we can check the star question. Star question, according to the new syllabus, we have to mention 6, maybe 7 different ideas, okay, to explain the thing, okay? And how we can link the ideas between the first to the second to the third to get the conclusion or the explanation or the description. Okay, how can we make it logically common sense what we are explaining, what we are describing? The linkage, okay, between, there's 2 marks on it. So to get from the first idea to the third idea and to get from the fourth idea to the sixth idea, finally to the conclusion or the description, there's another 2 marks, okay, out of the 6 marks. So the 6 ideas, okay, can give you only 4 marks if you are not make it tight or organized. If you make it tight or organized, you can get the other 2 marks to get 6 out of 6, the total mark of the IGCSE. Now, this question, I'm going to do it later on, okay? I'm going to answer it later on. I'm going to write it down as homework for my students that they are registered for this course. I want to see how they can answer this question, okay? And later on, okay, I'm going to explain it with them because it takes time from us, okay? You are asked to determine the acceleration of free fall of the surface of Earth, G, using a free fall method in the laboratory. Free fall method in the laboratory, okay? A star question. Describe the apparatus you use, 1, the measurements you take, and 3, explain how you get how you will use that to determine the value of G. Okay, I'm going to do it later on, not now. Okay, and the same thing for part B. Give 1 precautions that could be taken to ensure the accuracy of your measurements. Okay, later on, this is January 2009 question 15, but the idea, okay, they keep repeating the same questions from while to while. We are going to do full past papers at the end of this course, okay, to make the student prepared for their exams, inshallah. Now, vertical motion during free fall. Vertical motion during free fall. If I drop my phone, okay, and for example, a big a bag, okay, I have a big bag that has a lot of books, okay, and I carry both of them and I drop both of them from my window here, okay, which one will lands on the ground first? My phone, which is light, okay, 300 grams approximately, or my bag, which is approximately 10-12 kilograms? Which one lands on the ground first? The mobile or the bag? Thank you, Shahid. Thank you, Yusuf. Excellent. Who else? Yeah, send me on the chat. Whatever you want. What do you think? Don't drop your phone from the window and see, okay? Mobile because of air resistance, bag, both. Thank you, Muhammad. Okay. طيب, look here. شوفوا يا شباب. I'm talking about my window here. It doesn't have that high height to the ground. So that means my phone and my bag, when I release them, both of them will land on the ground at the same time because they have same acceleration, which is 9.81 gravity acceleration. And these objects, they are not affected by air resistance. Like if I bring a balloon and I release it, okay? Or I bring a paper, flat paper, not, okay, scratch paper, okay? Or a feather. Why? Because I'm not telling you anything about density here. So they didn't reach very high speed, or they didn't reach, they don't have low density or big volume or large surface area to be affected by air resistance. So that means the bag and the phone, they will reach the ground at the same moment. So if there's no air resistance, I didn't mention anything about air resistance yet. I didn't mention anything about forces yet. If all objects, they fall on the ground at the same time, and you can check from that, you can go to YouTube and write for Neil Armstrong. He dropped a feather and a hammer, okay, from the moon's surface. Okay, he held both of them at this height, the hammer and the feather, and he released both of them, and both of them land on the ground at the same instant. That means, okay, slowly, because the gravity acceleration on the moon is slow. That means there is no air, and they fall with the same acceleration. Another video from BBC, they have a vacuum chamber that they put a bowling ball and feathers from the top of the chamber, okay, 30 meters above the ground. They vacuum it, okay, they pump all the air out from it, and they drop this ball and this feather from them, okay, and they land on the ground at the same moment. There's no air resistance. That means what, Yeshua? That means what? All. When I said all, that means all. All objects fall on Earth or other planets with the same uniform acceleration called gravity acceleration, and it is equal to 9.81 meters per second square, okay, on Earth. So that means why they fall. We didn't talk about forces yet. Why they do that? Because there is single force act on them. Okay, what is the force act on them? What is the single force act on them? Why they are falling down? Due to the single force acts on them, due to the single force. Who can tell what's the single force? Huh? Bravo, exactly. Single force acts on them, which is their weight, which is the weight. Okay, each object has different weight, but this is the single force, and this weight, it's equal to mass times gravity acceleration, as we're going to explain that. That's why there's only what? Yes, I said weight, I didn't say gravity. Okay, now because you are in AS Edexcel, okay, you can't say gravity by itself. You have to say gravitational force, or gravitational field strength, or gravity acceleration, or gravity of your eyes, okay? Don't say gravity by itself, okay? Because gravity has several meanings, several uses. Gravitational field or gravitational force or gravitational acceleration, etc., okay, is the word of that we're going to use it, okay? The terminology that we're going to use it. We're not going to say only gravity. ماشي? Okay. So the weight means it's the gravitational force. Let me write it down. Gravitational force. Okay. And now I'm going to show you a small thing about dropping or falling an object or bouncing ball. Okay. This graph, it's a very unique graph. Okay. For we are going to talk about it when we talk about displacement time graph, velocity time graph, and acceleration time graph. But any bouncing ball, whenever we release it, it starts from zero and fall down with a constant acceleration called gravity acceleration. And as it hit and bounces up, it will decelerate until it reaches the maximum height, then accelerate falling down, then bounce, decelerates, reach maximum height, falls down with the acceleration bounce. And every time the height that it reaches, it will be less because there's some energy dissipated to the surrounding or as internal heat energy or thermal energy in the ball, etc., etc. So next time, we're going to explain all this with details. If you have any question, you can stay online. If you don't have a question, you can leave and have a good night. يعطيكم العافية. السلام عليكم ورحمة الله.